And what makes the non-calculator questions sometimes tricky is they go back and see if you remember all of your exponent rules. Going back to grade 11, going back to grade 10. So for A, I look on my powers chart and 8 is in the same column as 2. So this is going to be a good thing. I can change my 8, and I'll put it in brackets, to 2 cubed. Do you remember your exponent rule for radicals?
When you have a fractional exponent, the like if it's cubed, that means the 3 is the denominator, and then whatever the exponent on the inside of the root is your numerator. So in this case, it'd be 1 over 3.
So in this case, because I have a cube root, I have 1 over 3. If I had a fourth root, it'd be 1 over 4. A square root, 1 over 2. Okay, exponent rules. I need, if I'm going to solve this without a calculator, I need the same power on both sides. What is your exponent rule on the right? If you have 2 cubed times 2 to the 1/3. Add, subtract, multiply, divide, guess.
Add.
When you use the guess strategy? When you've forgotten on a test, right? And you're like, better try one of them. So if I'm going to add these together, 3, I'm going to change 3 already to 9 over 3 and add 1 over 3. This is going to get 10 over 3. And so, look at this. Now that they're the same, I can go so x would have to equal 10 over 3.
Would we have to write so in the event we were doing a question?
No, you could just write x equals 10 over 3. I do it because I'm actually not doing a mathematical step there. I'm just doing an observation. And sometimes that's allowed in math, and sometimes that can cause you problems. In this case, it's allowed. Look at your numbers, 125 and 625. Do those ever happen in the same place on your power chart?
5.
5s. 125, I'm just going to take my time on this one. 125 is 5 cubed. This would still be in brackets to the 2x plus 1 equals cube root 625 is 5 to the 4. Let's deal with the radicals. So I'm going to keep this 2x plus 1 up here. Here, 5 cubed, a square root of that will be 5 to the 3 over 2. So the square root makes a half. That half gets multiplied by the 3. Here, the cube root makes a third. That third gets multiplied by the 4. We get 4/3. Power to a power, we're going to have to multiply. So 3 halves times 2 will give me 3x. And 3 halves times 1 is plus 3 halves. So this was our goal. We do all of that exponent work to get one power on each side with the same base, so that if you took out a different color and circle my exponents, by observation, can you see that if these two things are equal, what's in the green circles has to be equal? 5 to something equals 5 to something. Those somethings have to be the same. So I go, so at this point, the 3x plus 3 over 2 has to equal 4 over 3. Four over 3 minus 3 over 2. How do you subtract fractions? Need a common denominator. That'll be 8 over 6 minus 9 over 6 gives me negative 1 over 6. If you have a fraction, then you need to divide by 3. Dividing by 3 is the same as multiplying by 1/3. And so x is equal to negative 1 over 18. Encircle questions 9 and 10.